This is an optional video helping people that are struggling with problems where we have a change in period. So we're going to do 3 in degrees and then 3 in radians real fast. Cosine of 3x plus 5 equals 0. I know that that's true at pi over 2 and 3 pi over 2, or in this case, 90 and 270 since we're in degrees. So that means that 3x plus 5 has to equal 90 or 270. And that would be the case if I were just in 0 to 360. So I have x equals 85 over 3 if I solve the first one, or I have x equals 265 over 3 if I solve the second one. Now I know typically that I could just go around in a circle 360 degrees and then I end up getting something that's similar. But what we recall from previous chapters is if I have a cosine of 3 times x minus pi over 2 or something like that, I would recall that this 3 indicates that I have a change in the period. And so that period gets smaller. And so instead of a period of 360, I have a period of 120. So what that means is I have to say plus 120n instead of plus 360n. And then I would get all of the answers that I really needed to get in this particular problem. Tangent of 2x minus 10 equals root 3. Well, I know that tangent equals root 3 when y is root 3 and x is 1. That occurs at a 60-degree reference angle in the first and the third quadrants. So that means 2x minus 10 has to equal 60 degrees, or 2x minus 10 has to equal 240 degrees. So I end up with x equals 35, or x equals 125. Now notice that when I do this problem, tangent typically has a period of 180 degrees. So if I add 180 to each of these, I should end up being okay, except I have this 2 here. So because there's that 2, I really have to add 90 instead of 180 because my period changes. My period's divided by 2. However, in this problem, it's technically not inaccurate to leave the answer like this because notice that if I have 35 and 125 and I continually add 180 to those things, I will actually end up getting all the correct answers because 35 and 125 are 90 apart. It would be a little more concise to write my answer as 35 plus 90n, and this would be the preferred way to write the answer because if you notice, 35 and 125 are only 90 apart. And so when I continually add 180 to each of these parts, I'm going to end up getting 90 apart anyway. And that makes sense because the period of tangent is 180, but when I have this 2 there, that actually shrinks the period. Now, let's look at this problem. I separate signs with the same sign. So I have sine of 4x minus 18 equals 1/2. Sine is equal to 1/2 when my angle is a 30-degree reference angle in the first or second quadrant. So that means 4x minus 18 has to equal 30, or 4x minus 18 has to equal 150. So when I solve this, I get x equals 48 over 4, which I can simplify to 12, or x equals 168 over 4, which I can also simplify to 42. So I have 12 and 42. And normally what I would do is I would add 360 to each of these. However, because my period repeats so fast, I have to end up not adding 360, even though that would get me some of the right answers. I have to add 90 in order to get all of the correct answers because my period is going so fast. So I have 12 plus 90n and 42 plus 90n as my answers. Now, real quick, what if I had this exact same problem? So I have sine of 4x minus 18 equals 1/2. But instead of saying all degrees, I would say 0 to 360. Well, I still end up solving exactly the same. So I get x equals 12 and x equals 42. So I would end up with those answers. But I would not just get those answers because since the period is 360 divided by 4, which is 90, I would have to still add 90 as many times as it took for these things in order to reach my 360 limit because I'm only allowed to go from 0 to 360. So 12 plus 90 is 102. Then add another 90 and I get 192. Then I add another one and I get 282. And then if I added another 90, I would be at 372. That's too big. That would be over 360. So 42 adding 90 gives me 132, then 222, then 312. If I added another 90, I would be too big. So I actually end up with 8 answers in this particular modified problem where I have to have answers between 0 and 360. It's also worth noting that if I changed this to have answers between, let's say, negative 180 and 180, not only would I have to add 90, but then once I got to 102, I would have to stop and I would have to subtract values in order to get things to be between the interval that I actually wanted. Okay, let's do some problems in radians. Cosine of x equals 0. Well, I remember that cosine is equal to 0 at pi over 2 and 3 pi over 2. So 3x equals pi over 2 and 3x equals 3 pi over 2. So when I solve these things, I end up with x equals pi over 6 and x equals 3 pi over 6, which is pi over 2. Now, normally, I would add 2 pi n to these things, but because I have a change in the period, 2 pi over 3 is my new period. So I'm now going to add 2 pi over 3n to both of these values, and that would get me my answer. Tangent of 2x plus pi over 5 equals root 3. We remember that this is going to be at a pi over 3 or 60-degree reference angle. So pi over 3 and 4 pi over 3 are going to be what I have to set 2x plus pi over 5 equal to. So I end up with these things, and then I'm going to get a common denominator real fast, just to simplify things. So my common denominator will be 15. And then I have to make sure that I get the numerators correct. So I had a pi over 3 that becomes 5 pi over 15, and pi over 5 becomes 3 pi over 15. So 4 pi over 15 becomes 20 pi over 15. So now that I have the common denominators, I end up with, when I subtract 3 pi over 15, I get 2 pi over 15. And then I divide by 2, I get x equals pi over 15. When I do the same thing over here, I have 17 pi over 15 divided by 2 becomes 17 pi over 30. Now, when I do this, remember, tangent typically has a period of pi, but since I have this 2, I'm going to divide it by 2, and I have 90 degrees, or pi over 2. So x equals pi over 15 plus pi over 2n, and x equals 17 pi over 30 plus pi over 2n. Now, one thing to keep in mind is that this second one, just like in the first problem when we did this, the second one ends up being redundant. I don't need to write it, because if I added pi over 2 to pi over 15, I would end up with 17 pi over 30. So I don't really have to write it, but it's not egregious if you do. It's not like it's bad if you write a redundant answer. Now this problem, I have separate signs with the same sign again. So 4x minus pi over 12 equals 1/2. And so sine is 1/2 at pi over 6 and 5 pi over 6. So I have 4x minus pi over 12 equals pi over 6, and 4x minus pi over 12 equals 5 pi over 6. This is an easy common denominator to get, so I'm going to write 2 pi over 12 and 10 pi over 12. And then after I add things over, I get 4x equals 3 pi over 12, which is the same thing as pi over 4. And down here, I have 4x equals 11 pi over 12. So when I continue to solve these things, I have x equals pi over 16 and x equals 11 pi over 48. Now when I do this, I would typically add 2 pi n, but since I have a period change, I'm going to write plus pi over 2n to these problems. And that makes sense because the typical period of sine is 2 pi, but I am dividing by 4 because I have a period shrinking of dividing by 4 since I have a b value there.